So in this video, we see some exercises on Visual Basic for application in Excel. Before we start, let me just remind you how to open the Visual Basic editor. You have to press Alt plus F11, then you select the document, then insert module, and then you have to remember to save the document as .xlsm, so as macro enabled Excel. Otherwise, your Visual Basic functions will not work. So our exercises on Visual Basic are in section 2 of the exercise book. However, let's start with something very simple. So let's try to repeat the exercise we did on sheet first of laboratory.xls6 using a Visual Basic function. So let's see again what the laboratory sheet first of our laboratory documents contains. So this is our worksheet. So you see you have this small, I remind you, we have this small data sets about student. So what we want to do, the final exercise of logical functions was about evaluating if the language of the student is Italian, and if the student is enrolled in the first year of his degree, then we have to return X. Otherwise, if the language is German and the student is enrolled in a year larger or equal than 2, then we write double X. Otherwise, we leave the cell empty. So we saw how to do this using if logical functions. Let's see how we can do this in Visual Basic. So Alt F11 opens the Visual Basic editor. Right click, insert module. At this point, we can create our function using the keyword function. Let's call this function myFun, open parentheses. We need two arguments here, the language, comma, and year. So you see that arguments are separated by comma. Whatever is your list separator, here you use comma. When I press enter, Excel Visual Basic recognizes the keyword function, so it highlights it, and also add end function to close the function. So now I need basically to create an if block. So if language, be careful with variable names because it's case sensitive, so it's easy to mistype something. Be careful, otherwise Visual Basic will complain. So if language is Italian and year equal to 1, so see, for strings Italian we use quotes, for numbers we don't use quotes. Then good practice to put a tab to indent the code when you are inside an if or a for loop, so it's easier to read the code. And remember that Visual Basic return the variable to be returned as the same name as the function. So myFun equal to X. Otherwise, if the first test is false, you have to check using else if language equal to 0 and year larger than 1, then myFun equal to double X. So here I check if year is larger than 1 because it must be larger or equal than 2, so it means that it is larger than 1. Else, if none of the condition above is satisfied, then myFun equal to, and we leave the cell empty. And if to close the if block. So now let's go back to our Excel document. At this point I can use this new function as one of the other embedded functions in Excel. So equal myFun, open parentheses. Sorry, I mistyped. Equal myFun. First argument is the language, semicolon, because here I have to use the list separator. Second argument is here. Double click. Okay. So you see that the function does exactly what I want. And maybe in Visual Basic you can create, it's easier to read. Now let's move to something a little bit more interesting. Let's consider exercise 2.1. Again, we have to consider the document library.xlsx, in this case the worksheet VBA. So let's see what the worksheet VBA contains. So we have this data, engine type, kilometer, consumption, and then we have to compute the fuel cost. So we have to create a function in Visual Basic that compute the fuel cost for a given trip, given your engine type. The engine type can be gasoline, LPG, or diesel. If it is something, if the engine type provided by the user is something else, then you return a warning and use gasoline. The engine type is not mandatory; it's an optional argument. So if not specified, it has to be it is gasoline. You assume the following fuel cost within the function. LPG is 55 cents per liter, gasoline €1.25 per liter, and diesel €1.15 per liter. So in the function, we have to check the engine type. Given the engine type, we derive the fuel price. And then with fuel price, kilometers, and consumption, we can compute the fuel cost. This is exercise 2.1. So let's go back to our Visual Basic editor. We can create another function just after the previous one. So function. Let's call it x2_1, open parentheses. So the first argument is the kilometers. Second argument is the consumption. Third argument, optional, is the engine type, the fuel type. So note the difference. I forgot quotes at the end. Note the difference with respect to the previous exercise. Here we have this argument is optional, so I use the keyword optional, plus I give a default value. So it means that if the user does not provide a fuel type, VBA will use gasoline as fuel type. Okay, optional arguments are at the end of the arguments list. You can put an optional argument between mandatory arguments. So now, given that the default value is gasoline, I give the price, I take fuel price, I assign the fuel price the value 125, which is the default value. Then I check the fuel type to define the correct fuel price. If fuel type equal LPG, then fuel price is equal to 0.55. Else if fuel type equal diesel, then fuel price is equal to 115. At this point, I could close the if block, because if fuel type is not LPG and it is not diesel, then it means that it must be gasoline. And I've already assigned to fuel price the value of 1.25, which is the price of gasoline. However, the exercise tells me that I have also to check if fuel type is something not in the list and provide a warning message in that case. So again, else if fuel type, which at this point must be equal to gasoline, otherwise it is an error. So I check if it is not equal to gasoline, then it must be something else. So I can write an error message box and define it. Fuel type, I am going to use gasoline. And then I don't have to assign any fuel price, because I already assigned to fuel price the price of gasoline. And if at this point I have the fuel price, so I can compute the fuel cost x2_1. So I have to create a variable with the same name as the function, fuel price multiplied by kilometer divided by 100 multiplied by consumption. Okay, you have to divide by 100 because the consumption is liter for 100 kilometers. Okay, so now let's go back to our Excel document. Here in fuel cost equal x2 underscore 1, engine type, kilometer, sorry, it's kilometer, semicolon. We have to provide, of course, the value in the same order as the argument list, consumption, and then the optional argument. So the price, of course, is €5.50. So let's see what happens if I write here gasoline. Okay. What happens if I write something that is not in the list of the engine type, like H2O, message box, undefined fuel type, I'm going to use gasoline. See, and the price is 12.5. Okay, now let's consider exercise 2.2. So again, in this case, we have to repeat the exercises we did with the embedded functions. And in particular, we have to consider the worksheet statistics in library.exlsx. So we have to implement two functions. First of all, we have to implement a function in VBA that reads as input a range of cells and returns the average value. This is, of course, the same as the average function. Then we have to modify the previous function in order to create a new one that reads again a cell of range of cells plus a parameter and returns the average of the numbers above or equal the parameters. Also, the function must check that the number of cells above the parameter is larger than 0 and display an error message if not. This is basically equivalent to the average if function where the condition is larger than a given value. So we want to apply the two functions to column A and B of the worksheet statistics and compare the results with the two corresponding built-in functions. So let's take again our laboratory.exlsx document. Let's consider the worksheet statistics. So we have here column A and column B. So Alt F11 to open the Visual Basic Editor. So let's create the first function that computes the average of values of cells within a given range provided by the user. So function, let's call it x2 underscore 2. And then the argument is r as range, close parenthesis. Okay, so this is the way we specify that the argument provided by the user is a range and it is not a single value as in the previous cases. At this point, what we have to do, we have to iterate over all the values in R, sum up all the values and divide by the total number of cells. So we need an accumulator, a variable where we accumulate all the values in R. So we call it sum equal to 0. And then for each x in R, okay, so basically what Visual Basic will do here, we'll go through all the cells in R, assign the value to x, and then what we do, sum equal to sum plus x. Next. So if the range R is two cells, A1 and A2, this loop will first assign to x the value A1 and then assign to x the value of A2. At this point, we have in sum the sum of all the cells in range R, so we can compute the average x2 underscore 2 equal sum divided by r dot cells dot count. So you see you have some embedded functions provided with associated to variables, to ranges. So in this case, we can count the number of cells in R. Now let's go back to our document. Let's see if it works. So I do here VBA. Sorry, let's go back to VBA. Otherwise, every time, basically what happens every time I modify one of the worksheets, Excel recalculate everything in the whole workbook, so the function returns the error message. So that's a little bit annoying. Anyway, now it's sorted out. So VBA and Excel. So this is equal. Yes, equal x2 underscore 2 a2 a20. So the average is 0.22253. Let's see the result of the average function on the same range. It is exactly the same. Of course, we are doing exactly the same operation. So anyway, it's just to check that what we are doing is correct. Let's do the same also on sequence B. Average. So you see that the function the function I have created returns behaves exactly the same as the built-in function in Excel. So this is just to show an exercise. Of course, that's not very useful, but just to show an exercise how to use the provide a range cell as argument and how to iterate over the ranges, the cells in a given range. Now, the second part of the exercise instead asks us to implement a sort of average if. So the user provides also a parameter. We have to check to take all the numbers above the parameters, and we take the average of those values. So let's see how we can do it. Let's create function x2 underscore 2b. This is a little bit more tricky because we can't use this function here. We can't use this module here because we don't know how many cells are above the range. So function x2 underscore 2b. So r as range. Sorry again. Plus another parameter th, so our threshold. So you have to check that all the values above the threshold. So here I can't use count as above, so I have to do my own count. So while I iterate over R, I have to check if the cell is above the threshold. If it is above, I increment sum plus count, otherwise I do nothing. So sum equal to 0, count equal to 0 for each x in R. If x is larger than th, then sum equal to sum plus x and count equal to count plus 1. And then I close the for each loop with next. So you see, I iterate over all the cell in range R, but in this case I don't sum all the cells as I did before, but I check if x is above the threshold. If it is above, then I sum and I count, so the number of cells I have above. At this point I could take the average, but I can do this only if count is larger than 0. Otherwise I get I have a division by 0, so that will not work. So if count is not 0, then I can compute my average x2 underscore 2b equal to sum divided by count. Else, so if count is equal to 0, I write an error message box, no values in range are above and th, and I assign to the return value, to the return variable, the value 0, and if. Okay, so let's go back to Excel. So let's see a couple of examples here. Let's use sequence B, where number of values are more distributed, so we can play a little bit with the threshold. So let's create again examples of VBA in column F and Excel in the column G. So equal x2 underscore 2b, b2, b20 is the range of cells, semicolon. Let's see what happens if the threshold is 0.2, for example. So you see that the average is larger than what we had of the average of the sequence, which is 0.46. The equivalent function using the embedded functions is average if b2, b20 criteria is larger than 0.2. Okay, you see that we have the same result. Let's try another case where we have a larger threshold, and for instance 0.6. So you see that the average is again even larger. So average if, sorry, equal average if b2, b20 larger than 0.6. We have the same result. Now let's see what happens if the function cannot find any value because the threshold is too high, is above the larger value in the sequence. So equal x2 to b, again b2, b20, and then let's use 10 as threshold. So you see we have a message, no values in range are above 10. Okay, and the result is 0. If we do this in using average if, b20 larger than 10, we got division by 0. Okay, because of course there are no values, so when the function divides by the number of cells, it divides by 0. Okay, so now let's consider the final exercise on Visual Basic. So in this case, we're not going to use any predefined worksheet, so we have to create our work. We have to work on an empty worksheet. So here we have to create VBA function that reads a value as parameter, reads a range of cells, and find the cells, the cell, return the value in the range closest to the parameter. The function must skip all empty and non-numeric cells, so if the user in the range provides non-valid cells, so cells not containing numbers, we have to skip those cells, we don't care. If the target value cannot be found, because the range does not include any numeric value, then the function returns 0 and displays an error message. Okay. So let's go back to our Visual Basic editor and go ahead and create another function. So function x2 underscore 3. We have two arguments, r as range and y, the target value we are looking for. Okay, so what we have to do basically to find the closest value, we have to iterate over the cells in R, compute the distance between R and X, so the absolute difference, the absolute value of the difference. Okay, and then we need the closest one. So basically we iterate every time. Let's assume that we have already cells with a minimum value. We iterate. If the new distance is smaller than the previous one, we update the result and go ahead with the next element of the range. Otherwise, we skip it. Okay. At the end, we have the closest distance stored in the result. So to do this, we need to create one solution to have first minimum distance, to assign to the minimum distance a very large number, like min dist equal to 9999. Okay, we have to assign to the output variable already a value 0, and then let's also create a flag found which is set to false or 0, so that variable will be set to 1 if we find at least one cell in the range with a numeric value. Okay, this is used because if we don't have any numeric cell in the range, we have to return the error message. Okay, then we iterate for each x in R. Okay, if is empty x equal to false and is numeric x equal to true, then so I iterate over all the cells of R. I check that the cell is not empty and that the cell is numeric. Okay, if both are true, then I can compute the distance between x and my target value y. If this distance is smaller than the minimum distance, okay, then it means that I have another best value. So I assign to x2 underscore 3 the value of x. I update min dist, assigning it the value of dist, and then I set found to 1 because I have at least one value, one numeric value to be evaluated. I could set this before, but okay, that's same here. And if next. So at this point in x3 in x2 underscore 3 I have the value of x whose distance from x y is the smallest one. Okay, so at this point I'm ready to return this value. However, before doing that, I have to check that found is equal to 1. So I have to check that I entered at least once. I managed to find a value that satisfies both these conditions. So if found is different from 1, then message box, I could not find any numeric value, returning 0. Sorry, I forgot the quotes again. And then end if. Okay, if found is not equal to 1, it means that I never entered this value here. I never set a value to 3 to x2 underscore 3. So x2 underscore 3 is still equal to 0. And if and function. So once more, I iterate over all the cells. So let's assume that I have a value, a cell, which is the closest value to y so far. So whose distance is the minimum distance. If iterating, I find another value, whose distance is smaller, I update the output. I update min dist with the new distance, and I set found to 1. There is another function here. I don't know where it comes from. Okay, so let's see if it works. Let's go back to our Excel document. We have to create an empty worksheet. So let's set some numbers here, like 1. Sorry, same problem as before. I have to go to statistics and let me remove this one. Otherwise, I keep on displaying the message. 1, 2, 2.8, 3.3, 7 equal x 2.3 range, semicolon 3. And the result is 2.8. Let's try another one, like 1.9, and the result is 2. Now let's write some non-numeric values. This I leave it empty. Okay. Let's create the same function, including also those cells, non-numeric value. Again, I look for 1.9, and you see that it works and it doesn't complain. Finally, let's check what happens if, sorry, 3. I only provide these non-numeric, these cells with non-numeric values, semicolon 2. I couldn't find any numeric value, returning 0. So that's all.